So the volume of each of these shells is going to be generated by this circumference. Okay, so as we rotate that, we're going to get the circumference of the circle, which is going to be the width of the rectangle that we're going to use, the height, which is going to be f of x, and then we're going to give it that thickness dx. So each of these volume pieces is going to be 2 pi x times f of x dx, length, width, and height, okay, or length, width, and thickness. That's going to give us our volume piece. So the total volume then is when we integrate all those pieces. Okay, and we can just pull that 2 pi on the outside. So using that formula, we're going to generate the solid, and then we're going to integrate to get the volume of this. Okay, so we have this function here. Okay, it's going to have a 0. Well, it looks like 0 is going to be here, here, and here somewhere. Okay, so we're going to basically be taking this function, okay, from 0 to 2. We're just going to take this area here and we're going to spin that around the y-axis. And because we're spinning around the y-axis, we could either take slices and use dy, but in this case we're going to use the dx thickness of the concentric shell. So basically, again, we're going to take this rectangular piece, okay, give it a thickness of dx. Okay, the dx, just going to zoom in a little bit here. Okay, we're going to have a thickness of dx in here. And then we're going to integrate this. Okay, we're going to spin that around and to integrate all those shells. Okay, so let's set up the integral here. So we need to generate the circumference. Okay, the circumference of that shell is going to be 2 pi x. So each shell is going to be in a position of x. We're going to need the height of that shell, which is our f of x, x cubed plus 4x squared plus 3x. We're going to need to give it some thickness. Okay, the thickness is going to be our dx. And then we're going to integrate all that. We're going to integrate all that from, in this case, it looks like from x is 0 to x is 2. Okay, so notice that all our variable terms are in terms of x. We're using a thickness of dx, so that's important. It has to be consistent that way. And so now we can integrate this. So I'm just going to pull that 2 pi on the outside first, and then multiply through with the x. So we get x4, 4x cubed, 3x squared. And that's from 0 to 2. And then integrating that, x5 over 5, 4x4 over 4, 3x cubed over 3, and that's going to be the bounds from 0 to 2. Okay, nicely those coefficients cancel out. So calculating the volume then is 2 pi. Okay, so we're going to end up with 2 to the power 5 over 5. That's going to be, those 4's cancel out, so 2 to the power 4 is 16. Those cancel out. 2 to the power 3 is 8. And then our lower bound is 0. So that's going to give us 0. And so when we add this all up, we're going to get 24. And then we need to make it in the terms of fifths. So we get 2 pi 32 over 5 plus 120 over 5. Okay, so adding that all up, that we are going to end up with 152 times 2. The volume works out to be 304 pi over 5, and that's units cubed. Okay, so we did that using all these shells. When we unwrapped each shell, we had the circumference gave us the width, the f of s gave us the height, and the dx gave us the thickness of all those rectangular pieces that make up those cylindrical shells. Okay, let's try this one here. So we have y equals negative ln x. Okay, so we're going to draw in our negative ln x function. Okay, it's going to look something like that. We're going to have y-intercept of 1. And we want from 0.05 to 1. So we want that area in here. We're going to take that area in there, and we're going to rotate it around the y-axis. Okay, so we're going to rotate it around there. We're going to generate kind of like a volcano shape with a kind of hole in the cylinder in the middle. I'm just going to shorten that up a little bit, so it's going to look like that. Okay, going through there. And so we're going to need to set this up. Okay, so to set this up, we need the circumference of the circle. I'll do this in green so that we can kind of keep track of this. So rotating it around here, I'm going to generate a circumference based on the position of x. Okay, so the x position is going to be radius of that circumference, so it's going to be 2 pi x. I want the height of that. Okay, so the height is going to be, height of those rectangles is going to be f of x. So in this case, it's going to be negative log x. Okay, so that's going to be the circumference times the height. We need to give it some thickness, dx. And then we need to integrate that to get the volume. Okay, so there's our integral. We have length times width times thickness. Each of those rectangles, we're going to sum up from 0.5 to 1. The thickness is dx, so our bounds are going to be along the x-axis. Our variables are all in terms of x, so that's all consistent. Okay, so then we're going to go volume is equal to 2 pi. We'll take the negative out as well. From 0.5 to 1, x log x dx. Okay, so if we've done integration by parts, we can actually solve that by integration by parts. We're just going to use this here. So if we haven't done integration by parts, you're going to need a formula for this, because without integration by parts, you cannot integrate this. Okay, so there's our formula there. We're just going to use that formula. So we're going to end up with negative 2 pi, okay, and x log x dx. The integral is going to be 2x over 2 log x minus x squared over 4, and we're going to integrate that from 0.5 to 1. Okay, so then plugging that in, so we're going to end up with 1/2 log 1, which is 0, minus 1 over 4, okay, minus, okay, so that's my upper bound. Plugging in my lower bound, I'm going to get 1/4, so 1/2 squared divided by 2 is 1/4 divided by 2, so it's going to be 1/8 log of 0.5 minus, if I plug that in there, I'm going to end up with 1 over 16. Okay, so that's my, well, I can work that out. Simplify that first before I work that out. It's going to be negative 2 pi times, it's going to be negative 4/16 plus 1/16, so it's negative 3 over 16 minus 1 over 8 log 0.5. Okay, so I'm just going to type that in my calculator, see what kind of volume we get with that. So negative 3 over 16 minus 1 over 8 log 0.5. Okay, and then times negative 2 pi. And so we're getting an area or volume of 0.633. Okay, so I'm going to round that to just 0.63. Okay, so the volume is 0.63 units cubed.